this is Emily Ransom, your business math professor. The results for Chapter 10 homework were pretty low, so I'm going to go through some of those problems and explain those, some places where maybe you tripped up. You do have a test on this material tomorrow night, so the numbers that I'm showing you are going to be different from yours in a lot of cases, so just bear that in mind, but I'm just going to try to show you some places where you may have tripped up. Okay, so this first one, we are calculating simple interest and maturity value. Remember, maturity value is the principal plus the interest, so that's the total that you're going to pay back at the end of the year. We are given principal, interest rate, and time. And in computing interest, that equation is interest equals principal times rate times time. So when we started out with this, we were talking about time in terms of months. So we have 12 months. And so in our time fraction, we're going to have months on the bottom as well, stated in as the number of months in a year. So our actual time is 12 months, but also on the denominator we're going to have 12 months. So this is the time fraction in this equation, 12 over 12. Now remember, for the interest rate, you have to take this percent and change it to a decimal to go in the interest equation. So to change the interest rate in a percent to a decimal, you're going to take away the percentage sign and you're going to move the decimal point 2 places to the left. So originally the decimal point is here. You're going to move it back 2 places so that it's here. All right. Principal, we insert here. So principal times rate times time equals interest. So if we multiply out 6,600 times 0.04 times 12 over 12, which is equal to 1, this is equal to 1, then the answer we get is $264. So we would fill that in up here in the simple interest block, which when you first see this problem is blank, okay? The next thing we have to calculate is maturity value. And to calculate maturity value, we're going to start with principal, and we are going to add the interest. And we get $6,864 as the maturity value, okay? All right, this is learning objective 1. So if you're having trouble with that, go back and review that. It is calculating simple interest for months and years, and right now we just started out with months. All right, let's look at the next one. In this one, we started looking at simple interest in terms of days, okay? So we're going to be using this days in a year table. We are looking for the exact amount of time that the loan is outstanding, and then we're going to compute the interest and then the maturity value. So in order to find the exact number of days, we're going to use these 2 dates, the date borrowed and the date repaid. And we're going to look them up on the days in a year table. So when we go look up June 11th, so you're just going to click this days in a year table. So this is your day of the month. And these are your months. Let me move this over here. There we go. Okay, these are your days of the month, and these are your months of the year. So if we go look at June 11th, the number associated with June 11th, see we're on the 11 row here, and in the June column. It is 162. And the number associated with March 9th, here's the March column, and the 9 row is 68. All right, once we have that, we're going to go back to our problem. Let me scoot this back over. Okay, so we have 162 days and 68 days. We're going to take that larger number, 162, and subtract the smaller number, 68, and that gives us the number of days the loan is outstanding. So that is our exact time, 94 days, okay? To calculate the interest on this, we're going to simply use that same formula. Interest equals principal times rate times time, okay? Now, let's look at the principal. That one is the easiest part of this formula to fill in. So here's our principal, and here it is in the formula. Let's look at the interest rate next. Remember I said you have to change this to a decimal number. So take that 9%, drop the percent sign, and move your decimal back 2 places. And the decimal equivalent is 0.09. Now, we calculated the exact number of days, and we know that the denominator has to be, if we're talking about days, then we also have to express the denominator of the time portion of this function or this formula in number of days, okay? So the 94 is going to be our numerator, and on the denominator, we're going to use one of 2 methods. We're going to use the ordinary interest method or the exact interest method. So the ordinary interest method, it tells us to use that here. According to the ordinary interest method, there are 360 days in 1 year. So that is going to be our denominator. When we calculate all this out, we come up with $32.90, which we put in our interest blank. And then to get the maturity value, remember maturity value is principal plus interest equals maturity value. Maturity value is what you pay back at the end of the loan term. So at the end of 94 days, we pay back $1,432.90. Remember a trick that I gave you, or a tip about remembering which is ordinary interest and which is exact interest. Ordinary, the word ordinary starts with an O, and 360 has this O looking 0 at the end. So that's kind of how you can remember. The one with the 0, which looks like an O, goes with ordinary, which starts with an O, okay? Okay, number 3. Probably what tripped up most people on number 3 is are the dates. So we borrowed this money on July 12th, and we repaid it on January 8th. So we're passing over the end of the year. Everything else about this problem is exactly the same as the one before. Not the numbers, but just the concepts. So we are again using ordinary interest. So let's look at this date problem here. So July 12th, if we were to go to the days in a year table, I'm not going to go there, I showed you how to do that, but you're going to the July column and the 12 row, and you get the number 193. Then if you go to the January 8th date, which is the January column and the 8 row, you're going to get 8, okay? Now, we can't, like in the other one, we're not going to take 193 and subtract 8, okay? Because July 12th is actually when our loan originates, and January 8th is when it's repaid. So what we have to do is consider the number of days in the year. This is different than the interest assumption we're making in terms of exact or ordinary, okay? When we're dealing with the calendar, we're always going to use 365. So we have to go to the end of the year to calculate how many days we've used in the year from July 12th till December 31st. So 365 minus 193, okay, that's the first portion. And then we add the 8 days that we've gone into January of the next year. So this you're accounting for the portion of time. Let's just put it some year terms with this so you'll understand. So let's just assume this is July 12th of 2018, okay? That's the date borrowed. The date repaid would be January 8th of 2019, okay? So we have to take into account the number of days in 2018 and then the number of days in 2019. So in 2018, we have 172 days that we determined by subtracting 193 from 365. And then in January, we have to account for those 8 days. So we wind up with 180 days. And then down here in our formula, which is principal times interest times time, our numerator is the 180 days and the denominator is 360 days. Why? Because we are using the ordinary interest method, okay? Don't confuse this 360 with the fact that there are 365 days in the year that you have to use when you're considering how many days the loan is outstanding, okay? The only difference with number 4 is that you are using exact interest. This is an assumption as opposed to ordinary interest. Everything else is calculated the same way that I already showed you. These dates do not cross over the end of the year, okay? We're just going from May 9th of one year to August 14th of the same year, okay? However, when we go to solve the interest equation, we have principal times rate times time. So we have those 97 days. The denominator, when you're using exact interest, is 365. That is the only difference in this problem. Okay? So you have to pay attention, complete the following using exact interest. The last 2 problems said complete the following using ordinary interest. All right? And I'll let you see that solution so you can work through that. All right, I'm jumping to number 6, and here with this problem we start solving for different parts of our formula. So traditionally we've been calculating interest, and that formula is interest equals principal times rate times time. Now we're going to take that formula and switch it up, and all we're doing is solving for another variable in that formula. So in this problem we have to solve for time, okay? We know the principal, we know the interest rate, and we know the interest. So the formula we use is time equals interest divided by principal times rate, okay? So you see simple interest is we just plug that in. Principal, we plug in, and rate. Remember, we change it from a decimal, from a percentage to a decimal number. So multiply together these items on the bottom. 565 times 0.08. And that equals 4520. And if you divide 226 by $45.20, you get 5 years. So the time is 5 years. Okay? So you get exactly 5. And whenever you're getting a whole number like that, we're considering it years in this situation. If we got, for example, 0.5, then that would mean it was half of a year, and we would change that over to months probably and say the answer is 6 months. Okay, this is Learning Objective 10-2 if you need to review this. All right, in this one we are solving for principal. So again, we're using a different formula. It's just the same formula, interest equals principal times rate times time, but it is we are solving for principal. Okay, instead of what we start out with is a formula that solves for interest. All right, I'm going to have to go to another video. I will